Alright guys, so let's go ahead continue our function unit. Okay, so in the earlier video we were looking at relations presented in a different format, and we were asked if these two terms were functions. Okay, so now we're gonna look at some cool graphs, and then we're gonna be asked, you guessed it, the same question: does this graph represent the graphable function? Now, if we're not given the graph, then we go by the straight definition of a function. You know, how can I tell if a relation is a function? Oh, a relation is a function if for each input value there corresponds exactly one output value. But now, what if a graph is presented? Okay, if a graph is presented, we're not going to list out all those ordered pairs. Okay, if a graph is presented, we're going to use my favorite. We're going to use the vertical line test. So the reason why this is called the vertical line test is because, you guessed it, we're going to use the vertical line. Let me get my bamboo. Okay, the reason why it's called the vertical line test is because we're going to use the vertical line to test out to see if the graph provided is a function. Now the question is, how can we use the vertical line test to make the call if this graph is a function? So the rule says if every vertical line intersects the graph at most once, then the graph is a function. So we're pretty much going to take our vertical line and we're going to slide it across the graph, and then we are going to see, or ensure, whatever word I'm trying to find, we're going to see if the vertical line intersects the graph in no more than one place. So let's go ahead and slide it. Okay, I need something flat, so I'm going to use the side of my bookmarker. Okay, so it's kind of like a big reveal. It's like, ooh, we're revealing. Okay, so we're going to take this vertical line, and I'm right-handed, so I swipe from left to right. Okay, so we're gonna go ahead, take our vertical line, which is the edge of this this bookmarker, and then see if the vertical line intersects at no more than one place at any given time. So I'm sliding. Oh, there you are. But at this point, let me move it forward. Okay, so at this vertical line right here, let me go ahead and use a highlighter for dramatic effect. Okay, so unfortunately this graph does not pass the vertical line test. Why? Because my vertical line intersected the graph at more than one place. Okay, I don't think I read the directions. I'm so sorry. Okay, so it's the directions read: determine whether the relation graph is a function, and then state the domain and range. So there's three questions. So one of them is the graph the graphable function, and then 2, we need to list the domain, and 3, list the range. The order in which you answer, like function, domain, and range, I don't really care. Just make sure you answer all 3. For me, I love pictures, so it's easier to for me to identify first if it's a function or not, and then I'll do the rest. Okay, so because this vertical line intersected that graph in more than one place, then this graph is not a function. So let's go ahead and write down one of our answers: not a function. Okay, so in order for me to highlight what's so cool about the vertical line test, the vertical line test, it's a nice visual way to see if each input corresponds to one output. So like in this case, I drew my vertical line at x equals -1. So when the input is -1, what is the output? So I'm gonna go ahead, locate -1, and then go on the x-axis, and then go up or down until I hit the graph. So if I go up, that's gonna say, let's just estimate, we'll just say that's about 3.5. I'm just guessing. Okay, and then when x is -1, y, or the output, could also be -3.5. Okay, what is the definition of a relation? A relation is a special backwards. What is the definition of a function? A function is a special relation where for each input value there corresponds only one output value, and in this case it's not happening. Okay, I think I'm saying too many words, but that's what happens when I get nervous. All right, now what is the domain? So the domain is the set of all the input values, or all the x's. The range is going to be the set of all the output values, or the y's. Now in this case, we have a graph, so we may write the elements of the domain and range slightly different. Going back to the earlier video, we had like a fixed number. Where am I? Over here. Okay, so the domain only 4 things, so we put them in we use set notation. Range, a fixed set of numbers. Cool. Now in this case, what are the input values, or all the x's? Okay, we have a bunch of x's that are used to create this graph. So if I read this from left to right, we have x is -2, we have x is -1, we have x equals 0 over here, we have x equals 1, we have x equals 2, but we don't just have those integers, we have like those fractions. So like 1, x equals 1, x equals 1.1, x equals 1.2, and so forth. So in this case, we have so many x values, so it's not feasible to list them one by one like we did in the earlier video. So in this case, we're gonna have to write it in interval notation. So interval notation, remember, interval notation goes from left to right. So what's the first x value that we see? So the first x value that we see is that -2. Okay, so in interval notation, the elements in the domain is from x equals -2 all the way to, so we have -1 and all those fractions in between. We have 0, we have 1, we have 2, and that's it. Okay, so what are the elements in the domain? It's all the numbers from -2 to +2, where both endpoints are included. So like again, we have -2, -1.5, and all those things that I want to say. Okay, range. Okay, the range is the set of all the output values, or in English, all the y's. Okay, now we also have lots of y's that are on this graph, that we also have a lot of output values, so it's not going to be feasible to write this in set notation. We're also going to have to write it in interval notation. Now it's like for range, you know, it's like, should I go from the bottom up or top to bottom? That's not something that we discussed before, so I'm just gonna tell you right now. We go like from bottom to the top, kind of like we go from negative to positive, same difference. So what is the lowest value of y? So I'm going to use my bookmarker, and the lowest value of y is at y equals -4. So we have -4 in the range, we have y equals -3 in the range, y equals -2, y equals -1, y equals 0, y equals 1, y equals 2, y equals 3, and y equals 4, and of course all those decimals in between. So in interval notation, the range is from -4 to +4. So we start at -4 and then we stop at +4, where both endpoints are included. So there's 3 questions. Okay, so is it a function? Is the graphable function? And then 2, spit out the domain and then the range. Something that I want to point out is that sometimes when students write down that the graph is not a function, they fail to identify the domain and range, but it's we have to identify the domain and range no matter what. Okay, problem B. So I want to know, does this graph represent the graphable function? So again, let's go ahead, use the vertical line test. I'm going to use my chopstick. It's not a chopstick, I'm lying to you, it's a bamboo stick from the dollar store. Okay, so let's go ahead, take that vertical line, and then make sure that our vertical line touches the graph in no more than one place at any given time. And it does. I'm gonna embarrass myself. When I was going to school and I did the vertical line, I don't know why I would like trace the curve, and then I'm like, I don't know why I do that. No, just go slide it across. Okay, but same difference. So let's go ahead, take our vertical line. I'm gonna focus this side, and then we make sure that the vertical line touches the graph in no more than one place. And in this case, the graph did pass the vertical line test with flying colors, so this is a function. Okay, now to list the domain and the range. So the domain is all the input values, or all the x's. If you need to speak to yourself, go for it. The range is going to be the set of all the output values, or the y's. That says y. Sorry for my sloppy writing. So in this case, we have too many input values, or too many x values that are used to create the graph. Remember, we don't just use the integers like x equals -1, x equals 0, x equals 1, and so forth. We have all those fractions and decimals in between. So for that reason, we're going to have to write the domain in interval notation. So the question is, where are we starting at? I like problem A because it's easier for me to say that, oh yeah, we're starting at x equals -2, and then we're stopping all the way to x equals +2. But for B, we have a line, so the line is going forever in both directions. So we don't have like a specific starting point for the x value. But we know that although we can't see it, x equals -2 is on this graph, x equals -3 is on this graph. So we're going to grab all the negative x values, and then we're going to go all the way to all those positive x values. So in interval notation, we have the interval from negative to positive infinity. Fantastic. What about the range? So the range is going to be the set of all the output values, or all the y. So we're going from the bottom to the top. So on the graph, you know, we have we're starting at from y equals -1, but we know that the buck doesn't stop here. I should stop saying those things that I'm not familiar with. Okay, we know that the line doesn't stop here. If we had the space, we would have y equals -2, y equals -3, y equals -4, and so forth. So in interval notation, we're coming from the negative side. So we're coming from negative infinity, and then we're stopping at, what are all those y values on the top? So we're coming from negative infinity. On the graph, we have up to y equals 6, but you know the drill. If we had space, we will have y equals 7, we will have y equals 8, and so forth. So it's going to be the interval from negative to positive infinity. So although the intervals are written the same, they have different meanings. For domain equals interval from negative to positive infinity, you know, we're thinking about the x values. Okay, for range, although it's the same interval written, it has a different meaning. We have range is the set of all the output values, or all the y's. Okay, 3 questions, 3 problems. How many problems are we doing? 8. So brace yourself. Pause and rewind if you need to. Okay, so to minimize the length of this video, I'm not gonna say so many words. I think I've said what I've had to say, so we're just gonna answer these quickly. Okay, so does this graph represent the graphable function? So if a graph is provided, let's go ahead and use our vertical line test. So you can use your pencil. I mean, do what you gotta do. Okay, I just like to use my book marker. So let's slide it, make sure it touches the graph in no more than one place, and in this case it does, so it is a function. What is the domain and range? So what are all those x values? What are all those y values? I'm going to trace it because I love coloring. So those x values, it's going to be the interval from, we start at -1, and then we end at x equals 3. So it's the interval from -1 to +3, where both endpoints are included. Okay, range, the set of all the y values. So we start at this and end at that. So we start at y equals -1, and we end at +3. Oh, I should have picked a better graph. Sorry. I don't want the intervals to look the same, but that's what I picked. You might need to change it for the next video. Okay, problem D for the grand finale. I said we're doing 8 problems, but it's gonna be 4 problems per page. Okay, so is this graph the graphable function? So let's go ahead, take our vertical line, slide it across, and slide it across and make sure it touches the graph in no more than one place. But in this case, this graph quickly failed the vertical line test. On the test, do you have to do a vertical line? No, I just do it for dramatic effect. You know me, I love to speak to myself. I love writing love notes. So for me, when I write the vertical line, when the graph is not a function, it kind of reminds me, oh yeah, this graph is not a function because it didn't pass the vertical line test, meaning this graph is not a function because my vertical line intersected the graph in more than one place. Okay, but do what you gotta do. Not a function. Cool. All right, domain and range. Let's go straight to the answer. What are the input values, or the x's? what a range, what are the output values or the y's. Do what you gotta do. Again, we have too many to like list one by one, so this is why we need to write it as an interval. So the domain, we're starting at x equals, where am I? X equals 1, and then we're going all the way to 2, 3, 4, 5, and forever. Okay, so we're starting at x equals 1 and going towards the positive direction. So it's going to be from 1 to infinity, where 1 is included. And again, remember, the infinities never get always get parentheses. They never get brackets because they don't represent a specific number. Range, this is a tricky problem, especially because we didn't graph these by hand, but don't worry, he'll do that in the next course. So it's going to be the set of all the output values, or the y. So what is the lowest value of y? So like on paper it looks like 2, okay, but remember the graph doesn't stop here. So let me go ahead color. So if I had the space and followed the curve, it will keep getting wider and wider and wider. Okay, same thing above, wider and wider and wider. Okay, that didn't look so good. Remember not to use green. Okay, so on the graph we have y equals 2, but if we had space we would have y equals what? Y equals 0, y equals -1, and y equals -2. So pretty much we would grab all the negative y. So the range is going to be from -infinity to on graph we have up to where am I? Y equals 6, but you know the drill. If we had the space we would have y equals 7, y equals 8, y equals 9, and all the positive y. So it's the interval from negative to positive infinity. Okay, so those are 4 problems. We have 4 more and then we're out. Okay, where's my paper? Okay, found it. So remember guys, pause and rewind as many times as needed. So same directions. I just put fun problem number 4 to remind me of the directions. So is this graph the graphable function? And whether it is or not, we still have to list the domain and range. So remember, picture provided, vertical line test. Okay, picture not provided, is just straight definition of a function. So let's go ahead, take our vertical line. Again, I'm using the side, and make sure that the graph does not intersect the vertical line in no more than one place. So we're sliding, and look at that, 1 point, 1 point, 1 point, 1 point. So yes, this graph passed the vertical line test with flying colors. So it is a function. Now, domain, remember, it's the set of all the input values, or the x's. Range, the set of all the output values, or the y's. So the domain, so what are the x's that are used to create this graph? So remember, we have all of these. Okay, so right here we have like the graph keeps getting wider and wider and wider. Okay, this is ugly. Okay, so if we had the space we would have x equals -6. If we had the space we would see that we have x equals -7. What I want to get at is that to create this graph we're gonna need all those negative x values. Okay, and then we keep going forward, we have up to like x equals 0, but if we have the space we would have like x equals 1, and we will have x equals 2. So pretty much to create this graph we need all those negative x values, and then we also need those positive x values. So it's the interval from negative to positive infinity. Hopefully I said what I wanted to say, because if not then I told you a lie. Okay, but the good thing is that the answer is right. Range, the set of all the how the output values, so all the y's. What are the y's that are used to create this graph? So we start from bottom to the top. So we have ends at both ends, so and then we're going towards the negative direction. So we're coming from, in terms of range, we're coming from the negative side and stopping at something. So interval from -infinity to, what is the highest value of y? So we have x equals 1, 2, 3, 4. This is exciting. I love using my bookmarker because I feel like it's the big reveal, like, oh look, we're getting there, we're getting there. Okay, yeah, this is why we don't do videos in the night. Okay, cool. All right, so in interval notation the range is given by the interval from -infinity to +4, where of course 4 is included. Fantastic. 3 questions, 3 answers. Okay, we got three more graphs and we're good. So now problem B, I want to know, is this graph the graphable function? So again, picture provided, go ahead, use the vertical line test. So we're going to take that vertical line and then make sure that it doesn't touch the graph in no more than one place. So we have, we slide it, and of course this graph does not pass the vertical line test out. Why not? Because the graph is actually the vertical line, so it's not a function. Okay, why not? Because it didn't pass the vertical line test. Where is my vertical line touching the graph? Is it touching it more than one place? Yeah, like everywhere I run. Okay, what is the domain? Oh, this was really spicy. Okay, so after I think like 5 problems or so, I'm getting used to, like, oh my gosh, I have to write the domain and range in interval notation. It's not a have to, it's more like if you have too many things to spit out, then you go ahead, write it in interval notation. But if you have like a short list, or a finite I should say, then you write it in set notation. Okay, so in this case, what is in the domain? What is the set of all x values that are used to create this graph? Well, this point right here, we have x equals 2. What about this one? X equals 2. Oh my goodness, x equals 2, x equals 2. So it doesn't matter where we are on this vertical line, the value of x is always 2. So what is the only input value, or what is the only x value that is used to create this graph? You said it, 2, dos in Espanol, sorry, in Spanish. So in this case, we're not going to write it in interval notation. We just put the 2, and then we can write it within braces. Okay, so what's the domain? Oh, the set of 2. No one speaks like that, so we'll just say 2. Range, if we only have like a few elements, then same speech, put in set notation. But if we have a boatload of elements, of continuous elements, then we write it in interval notation. So in this case, we're going to have to write it in interval notation. So what are the y values that are used to create this graph? So we are grabbing all the negative y's, and then we're grabbing all the positive y's. So in interval notation, it's the interval from negative infinity to positive infinity. I know it's a weird one. Okay, we're almost done, guys. Okay, problem, where am I? C. So does this graph represent the graphable function? So let's go from left to right. We slide our vertical line, making sure that the graph doesn't intersect the graph in no more than one point. Let me say that again. Let's go ahead, use the vertical line test, and make sure that the vertical line doesn't intersect the graph in no more than one place at any given time. So we're sliding a vertical line, and it doesn't touch the graph in no more than one place at any given time. So this is a function. Now the domain, so the x is the set of all x values. So we are grabbing all the negative x's, we are grabbing all the positive x's. So an interval notation is going to be from negative to positive infinity. And then the range, what's the lowest value of y? Negative 3. What is the highest value of y? Negative 3. Okay, so there's only one element. It doesn't matter where we are on this line, the value of y is always negative 3. So there's only one element. So if there's only one element, then we don't write it in interval notation. So in this case, it's going to be the set of negative 3. Cool. So I was going to stop right here, but you guys are overachievers, so I threw in a bonus problem, which was our last problem. Problem D, sorry, technical difficulty. So let me go ahead and trace this so you can see this better. Oh, I don't know how to trace. I need to go back to TK. All right. So let's. The question is this graph the graphable function? So we're going to take our vertical line. You can use your pencil or your bamboo stick, whatever, from the dollar store. And let's make sure that this graph does not intersect the graph in no more than one place at any given time. So we slide from left to right. It looks like it's only touching in one place, and it does. So it is a function. Fantastic. What is the domain? Okay, so on paper we have like we start at negative 3.5 per se, but you know that we have an arrow, so we have in our course we don't graph things like this by hand, but you can do it in the next course. If we had the space, this graph will keep going, will keep opening forever and ever. So in this case we are gonna grab all the negative x values, so it's gonna be the interval from negative infinity to, and then what's the x values on the right? So we have x equals 1, x equals 0, and if we had the space, this is terrible, I can't draw. Okay, I don't know how to draw and I'm the teacher. You know what, I can't fix this. I was trying to do something like this. Yeah, okay, but that didn't happen, sorry. Okay, so in this case, if we had the space, we would see that the graph would keep opening forever and ever, and will keep getting wider per se. I keep saying opening because that's how I speak, but it would keep getting wider. So we would have x equals 0, we would have x equals 1, we would have x equals 2, we would have all those positive x values. So in interval notation, what is the domain? What are those input values? It's going to be the interval from negative to positive infinity. Range, range, all the output values of the y. So the lowest value of y, again the graph does not stop at y equals negative 4. If we had the space, we would have y equals negative 5, negative 6, and you know the speech. So the range is going to be from negative infinity to positive infinity. I'm thinking of the, ¿cómo se llama? The Toy Story movie, to infinity and beyond. I should have said like, or however his name is, but I forget. Alright guys, that's my time. We did it.